What is aluminium? Aluminium is the 13th element of the periodic table. The color is silver, white metal. Aluminium is the most widespread metal on Earth, making up more than 8% of the Earth's core mass. And these are the facts. Physical properties of aluminium. The color is silvery white with a bluish tint. The hardness is pure metal is very soft, but it becomes strong and hard when it is alloyed. The ductility can be beaten into extremely thin sheets. Malleability is capable of being shaped or bent. Conductivity very good with electric current flow and as a heat conductor. Corrosion. For the chemical properties of aluminium, from the table, this is symbol. The occurrence occurs only as a compound, principally in bauxite. The oxidation mostly in moist air. It combines slowly with oxygen to form aluminium oxide. Reactivity with acid, react with many hot acids. For the water, react quickly with hot water. With alkalis, it reacts with alkalis such as sodium hydroxide and lime water. The compound, a mixture of aluminium, oxygen, and other elements, produce bauxite. Bauxite is an aluminium ore and is the main source of aluminium. Alloys. When combined with elements such as copper, silicon, or magnesium, it forms alloy of great strength. Application of aluminium. Aluminium is usually used for precision tubing in motor vehicles, refrigerators, air conditioning, solar panel, and etc. Power lines. This is because aluminium's lightweight and durability would make it an ideal candidate for transporting energy across long distances. For use for rolled aluminium products, heat sinks for cooling CPUs and graphic processors, construction like skylight, bridges, ladders, etc. Application of aluminium in transportation. Excellent strength to weight ratio, make prime material for the construction of aircraft. These same properties of aluminium means various alloy are also used in passengers and freight rail cars, commercial vehicles, military vehicles, ships, boats, and etc. It's very light and strong, prove a very ideal material for aircraft. There are other applications for aluminium. One of them is marine application. For marine application, these are the examples. For building and architectures, aluminium also is used for the foil, as you can see here.
Magnesium. What is magnesium? Magnesium is a chemical element with symbol Mg and atomic number 12. It is a shiny gray solid which bears a close physical resemblance to the other 5 elements in the second column, which is group 2 or alkyne earth metal in the periodic table. All group 2 elements have the same electron configuration in the outer electron shell and a similar crystal structure. Physical properties of magnesium: color, gray-white metal, phase, solid, crystalline structure, hexagonal, ductility, it can be beaten into extremely thin shape. Hardness, relatively soft, melting point at 923 Kelvin, boiling point at 1360 Kelvin. Chemical properties of magnesium: chemical formula, Mg. Flammability, burns in air with a bright white light. Alloy: magnesium alloy are light but very strong. Oxidation: it combines with oxygen at room temperature to form a thin skin of magnesium oxide. Application of magnesium: magnesium alloy are in use around the world in a variety of different applications. It is a preferred material when looking for weight reduction without compressing overall strength. The vibration damping capacity is also beneficial in applications in which the internal force of high-speed component must be reduced. The most common applications are aircraft and missile components, bicycle and other sporting goods equipment, ladders, luggage, and others. More application of the magnesium application. Aerospace application. Car, vans, and trucks are not the only vehicles that have incorporated magnesium in their design. The aerospace industry has a long history for using the metal in many applications, both civil and military. In the automotive application. In the medical application, in the first half of last century, magnesium was first introduced in the medical industry as an orthopedic biomaterial. There are many characteristics and properties that make magnesium a very attractive option for use in implant and similar applications. In the electronic application, in the current market, small and portable electronics are trending upward. Many magnesium alloys being used to replace plastic are just as light, but they are much stronger and more durable. In the non-structural application, magnesium is not solely used for the creation of structural products. Its unique properties as an element allow its use in a variety of non-structural applications. Sport application. Similar to its applications in other industries, magnesium is prized for use in sport equipment due to its lightweight and impact resistance.
Next, we are going to discuss about the phase diagram of MgAl alloy. And here is the diagram of MgAl alloy. It contains two solid solutions, Mg and Al, or alpha and delta. And here is the definition of both alpha and delta. Next is the example of isothermal reaction that exists. The first one is eutectic reaction. The second one is also eutectic reaction. And the last one is peritectic reaction. Next is the solidification process of MgAl alloy. The first example is about eutectic steel. The second example is about hypoeutectoid steel. The third and the last example is hyper-eutectoid steel. Next is methods of improving material properties, which is heat treatment. Treatment we are going to discuss is annealing. The procedure of annealing of MgAl alloy. Next is the purpose of annealing. Next is the microstructure formed after annealing. And lastly, it is the example application of treated material.
So now I will describe about the heat treatment of normalizing. What is normalizing? Normalizing process is a heat treatment process for making material softer but does not produce the uniform material properties as produced with an annealing process. Normalizing of magnesium aluminium alloy. The procedure. The first step is heating hyper-eutectoid steel above 18 and for the hyper-eutectoid steel above ACM. The second step is soaking. The third step is cooling at the end. The most common reason for the normalizing process is to adjust mechanical properties to suit the service condition. The other purpose of the normalizing is to relieve the internal stress, to refine the grain structure, and to improve the machinability. Normalizing microstructure form. The structure produced by normalizing is similar to that of annealing, but air cooling is faster than furnace cooling. Thus, the normalized steel possesses fine grain than annealed steel. Application of normalizing. First, ferritic stainless steel stamping in automotive industry, nickel-based alloy in the nuclear industry, and carbon steel may be normalized after it is cold rolled to reduce the brightness caused by work hardening.
Next heat treatment is quenching. Quenching by definition is rapid cooling. It prevents undesired low temperature process such as phase transformation from occurring. These are quenching procedure listed step by step. Take note that there are different types of quenching medium to choose based on desired condition. Main purpose of quenching is to increase the steel or alloy hardness. However, there are some compromises need to be made as the brittleness increase as the hardness increase. These are some of the application of magnesium alloy.
Heat treatment for tempering. What is tempering? These are the meaning and the steps for tempering. Also the procedures for the tempering of magnesium and aluminium. The purpose of tempering. Microstructures. This is from before and this is the after. These are the examples of tempering a final product.